Okay, guys, uh, you're welcome to my channel. Today, we are going to be looking at stock boats, the sizes, how to determine the sizes of a stock boat, and also the size of spanners that goes with them. So let's quickly dive into it. First and foremost, we'll start by listing the sizes of stud boats from the least to the highest, according to the ascending order. Of course, you are aware that what we'll be treating today is a stud boat, fastening boat used for flanges. That is according to ASME 16.5 for flanges. So stud boat, that is what we'll be treating for today, the sizes of stud boats. Most times what we'll find out from the isometric drawing, we'll find out that most times the stud boat sizes are written in fraction numbers, sometimes in decimal numbers, and sometimes in metrics. So here I'm going to explain everything so that we're all going to understand how you can be able to know a size of a stud boat that is given in fraction. Then you can trace it down to metrics. So today I'll be showing everybody if a size of boat is given in metric, then you can also convert it to fraction or a decimal. So whichever one that is being written in isometric, you can easily identify which is it, from the fraction to the decimal place and that of the metrics. So without wasting much of our time, let us quickly dive into it. Okay, stud boat size in inches and in metrics, that is in millimeter. From this picture you're seeing above, you can as well see the sizes of the stud boats from the least. I list them from the least to the highest, that is in ascending order. The least we have here is 3/8, that is in inches. 3/8, that is in inches. Then you can see that this 3/8 is in fraction. Then I have to break it down to decimal place, which is 0.375 inches in decimal place. Then in the other hand, you can see where I wrote 10 mm, which is in metrics, in millimeter. That is the size of the stud. That is when you get the stud and you measure it, that is what it's going to give you. You understand? Then number two, that in number two we have 1/2 inches. 1/2 inches, when you break it down, it will give you 0.5 in decimal place, 0.5 inches, which is 12.7 millimeter. And number three is 5/8, which is 0.625 inch, which is also 15.8 millimeter. The other one is 3/4 inch, which is also 0.75 inch, gives 19 millimeter. The other one is 7/8 inch, which is also 0.875 inch, gives also 22 millimeter. Then we have a 1 inch, which is 1.0 inch in decimal place, which is 25 millimeter. Then in number 7 we have a 1/8 inch in decimal place, which is 1.125 inch, gives us 28.5 millimeter. Then number 8 we have 1/14 inch, which gives us 1.25 inch in decimal place, which is 31.7 millimeter. Then from the second page you can see from there, number 9 is a 1/3/8 inch, which is 1.37 inch in decimal place, which is also 34.9 millimeter. Then number 10 we have a 1/12 inch, which is 1.5 inch in decimal place, and it is 38 millimeter. Also we have 1/58 inch, which is 1.625 inch in diameter, 1.625 inch in decimal place, which is 41 millimeter. We have in number 12 1/3/4 inch, which is 1.75 inch, gives us 44 millimeter. Number 13 we have 1/7/8 inch, which is 1.875 in decimal place, gives us 47.6 millimeter. And number 14 we have 2 inch, which gives us 2.0 inch in decimal place, which is 50.8 millimeter. Then number 15 we have 2/18 inch, which is 2.125 in decimal place, which is also 53.9 millimeter. Mind you, those ones we write 0.8, 0.9. You can as well approximate it to the nearest whole number, and that will give you the correct answer. Okay, number 16 we have a 2/114 inch, which is 2.25 inch in decimal place, gives us 57 millimeter. Number 7 is a 2/3/8, which is 2.375 inch in diameter, in decimal place rather, which is 60 millimeter. Then number 18 we have 2.5 inch, which is 2.5 inch in decimal place, gives us 63.5 millimeter, and we can take it to 64 millimeter as well. Okay, what I just did now was to show you the sizes of boats that we have, and ASME 16.5, the stud boats that are used in fastening of flanges, tightening of flanges. I showed you the sizes we have, from the least, from the smallest to the biggest, which happens to be in decimal, which happens to start with a fraction, then we have to bring it down to decimal, then finally to matrix, which is in millimeter. So right now we are going to dive into the calculation on how to convert the sizes from fraction to to decimal place, then to matrix. Reason is being that whenever you are given a size of both, whether in a fraction or in decimal place or in matrix, you can tell which size of boat they are talking about, and you can easily look for it and get it for a job you want to use it for. Most of us get confused when a size of boat is given in fraction. Probably you are aware of the metrics and the size of boat is given to you in fraction. It might get you confused if you are not careful. So this tutorial video, we're going to look at it so that whenever a size of boat is given to you in matrix, you can be able to identify it if it is written on the body in fraction. So before we quickly dive in, let me also explain further. In matrix, when a boat is a size of boat is given in matrix, it is written as M, then the number. For example, if the length, if the diameter of the stored boat is for example 41 mm, for example, instead of writing it 41 mm, we can just write M41. That is in matrix. M41. What it means is the diameter of the boat is measured 41 millimeter, and it is written as M41. So probably they might give you a boat that is written as M41 and they ask you to look for it in fraction. How do you get it? Or if it is given to you as in fraction, for example, it is given as 5 by 8 inch, then you have to convert it to 41 millimeter, which is also M41. Okay, let's quickly dive in. I'll be showing you how to convert it. Now we are starting with 3 by 4, which is 0.75. You multiply by 25.4 in inches, it gives you 19.05, which is in millimeter, which is in matrix. So 7/8 gives you 0.875 multiplied by 25.4, as converting it to matrix gives you 22.2, which is M22. So we'll go over to 1/2, which is also 0.5. We multiply 1/2, which is 0.5, multiply it by 25.4, that is converting it to millimeter, gives you 12.7, which is M12 or M13 rather. 5/8 gives you 0.625, multiplied by 25.4 gives you 15.8, which is M15.8 or M16. Where you approximate, it gives you M16. We are trying to convert to spanner size, and we are starting with 5/8. We are trying to check the size of spanner that can work on this size of boat. So we are starting with 5.8, 5/8, that is in fraction, 5/8, which is 0.625. Then there is a formula for that. That formula is you multiply this decimal with 40. You multiply it with 40, then you add 2 to it. 40 plus 2, then it gives you 27. So it means 27 is the size of spanner that can work with 5/8. So the next one is 3 over 4, which is 0.75 multiplied by 40 plus 2 gives you 32, which is the 32 size of spanner that you can use with 3 by 4. Then the next one is 1 over 2, which is 0.5. You multiply by 40 plus 2, it gives you 32, which is the size of spanner that we use for that. Okay, here 7 over 8, we started with 7 over 8, continue with 7 over 8, which gives you 0.875 multiplied by 40, it gives you 35 plus 1. The formula changes here. Take note here, the formula changes from, instead of plus 2, you now do plus 1 here. You understand? So it gives you 36. 36 is the size of spanner that will work with 7 over 8 size of knot stud bolt. Then we go over to 1 inch multiplied by 40, or okay, take it to decimal place, multiply by 40, and then you add 1 to it, it gives you 41. 41 is the size of spanner that will work on 1 inch size of stud bolt. Then I will move over to 118. 118, it gives you 1.125 in decimal place, multiplied by 40, then plus 1 to it, it gives you 46. 46 is the size of spanner that will work on 118 size of stud bolt. Then we'll move over to 114. 114 gives you 1.25 decimal place, 1.25, sorry, 1.25 times 40 gives you 50. Here the formula changes here. Instead of plus 1, we are not going to add anything to it again, and this is how it will remain till we get to 100. So we'll move over to the next one, which is 138. 138 gives you 1.375 inch in decimal place, multiplied by 40, it gives you 55. 55 is the size of spanner that will work on that one. Then 112, that is 1.5, gives you 1.5, multiplied by 40 gives you 60. 60 is the size of spanner that we use to lose a stud bolt of 112. 158 gives you 1.625 inch in decimal, multiplied by 40 gives you 65. 65 is the size of spanner. 3 by 4 gives you 1.75 inch in decimal place, multiplied by 40 gives you 70. 70 is the size of spanner. And we have a 178. 178, it gives you 1.875 multiplied by 40 gives you 75. 75 is the size of spanner. Then we get to 2 inch, the size of stud bolt. 2 inch size of stud bolt, it gives you 2.0 in decimal, 2.0 inch in decimal place. 2.0 in decimal place. 2.0 multiplied by 40 gives you 80. 80 is the size of spanner that will work. Then we'll work on 1/8, gives you 2.125 inch in decimal place, which is multiplied by 40, which is going to give you 85 millimeter. It's the size of spanner that we use. Then we go over to 1/4. 1/4 will give you 2.25 multiplied by 40 gives you 90. 90 is the size of spanner. Remember, it is in a millimeter, which is metric size of spanner. And 2/3/8 gives you 2.375 inch decimal place multiplied by 40 gives you 95. 95 is the size of spanner. 2 gives you 2.5 inch in decimal place multiplied by 40 gives you 100. 100 is the size of spanner. So guys, this is where we'll call it a day. Thank you and may bless. Please remember to like and share. Remember to like and share. Also follow and subscribe for our next video. Next video will be looking more on the code, the ASME codes, and the flange management system. We'll be looking into that. The length of both as well, we'll be looking into that. Thank you. Please do not forget to like and share. Thank you and bye bye.